All right, let's dive in. If you're a data scientist, you know that feeling, right? Your Python script starts simple, but then it just grows and grows. Well, today, we're going to talk about the single biggest step you can take to fix that, to start thinking like a professional ML engineer. We're going to master Python's most powerful tool for organization, the module.
So here's the plan. First, we'll talk about a problem I'm sure you've all faced, the giant monolithic script. Then, we'll introduce its super elegant solution, the Python module. We'll dig into why this is an absolute game changer for MLOps. I'll show you a professional structure you can literally start using today, and then we'll cover a critical mistake that almost everyone makes when they're starting out.
Okay, part 1, the monolithic script problem. Let's really talk about this, because it's something that quietly sinks so many ML projects before they even get off the ground.
So, be honest with yourself for a second. Is your main project file, whether it's a PyScript or a notebook, just getting longer and longer? You know how it goes. You start with some data loading, then add a little cleaning, then feature engineering, model training, evaluation, and bam! Before you know it, you're scrolling through a 1,000-line monster. If this sounds a little too familiar, don't worry, you're definitely not alone.
You see, the real problem is that this one giant file becomes this tangled mess of code. Trying to find a bug in there? It's like finding a needle in a haystack. And how in the world are you supposed to write a clean, targeted test for one specific function when it's buried in the middle of everything else? And collaboration, forget about it. You and your teammate are just constantly creating merge conflicts, stepping on each other's toes. It's a total nightmare.
Section 2. Introducing Python modules. So, how do we escape this monolith nightmare? Well, the answer is actually beautifully simple, and it's built right into the Python language itself.
So, at its very core, a module is just a file that ends in .py. That's it. But the key phrase here is self-contained namespace. Just think of it like a labeled box. You can put all your data loading functions into a box called data.py. All your model architectures go in another box called models.py. Suddenly, you've brought order to the chaos, and you don't have to worry about function names clashing anymore.
And here's something really cool that a lot of people don't realize. Modules aren't just some abstract concept. They are actual Python objects that you can play with. Once you import a module, you can literally ask it, hey, where do you live on my computer? Using _file_, or you can see a whole list of everything inside it using the dir function. This ability to inspect your code just makes everything so much more transparent and easier to manage.
All right, Section 3, the MLOps advantage. Now this is where we level up from just organizing code and start unlocking some serious MLOps superpowers.
Using modules the right way gives you 4 huge advantages. First, obvious one, organization. You can separate your code by what it does. Data, features, models. Second, reusability. That awesome feature engineering function you wrote, now you can import and use it in your training pipeline and in your live production inference service. No copy-pasting needed. Third, collaboration. A data scientist can be tweaking the model in models.py while an ML engineer is optimizing data loading in datasets.py, and they won't interfere with each other. And finally, and this is a big one, testability. You can now write small, focused unit tests for each piece of your system to prove that it actually works.
Section 4, a pro-level structure. So you might be wondering, okay, I get it, I should use modules, but is there a right way to structure them? For serious MLOps work, the answer is a huge yes. Let's look at the pattern the pros use.
The big idea here is to separate your code into layers based on its job. At the very core, you have the domain layer. This is your pure, predictable ML logic. Think model definitions, feature transformations. This code knows nothing about files, databases, or APIs. Then you have the I/O layer. That stands for input/output. This is the only part of your code that talks to the outside world. It loads data from a bucket, it calls an external service, whatever. And finally, the application layer is the conductor. It orchestrates everything, taking data from the I/O layer and passing it to the domain layer to actually run a training job or serve a prediction. This separation is what makes your core logic incredibly easy to test and reuse.
Okay, last section, and this is a really important one. Section 5, the import trap. See, with the power of modules comes one major risk. And avoiding this trap is what really separates the beginners from the seasoned pros who deeply understand how Python works.
So here's the danger. The very first time you import a module in Python, Python actually runs the code in that file from top to bottom. So if you have code just sitting at the top level of your file that does something, like printing to the console, accessing a file, or even worse, loading a giant dataset into memory, that action is going to happen automatically the second someone imports it. This can make your program slow, unpredictable, and cause all sorts of weird, unintended side effects.
So what's the fix? Look at this. On the left, you see the dangerous way. That load-heavy dataset function runs the moment you type import. On the right is the safe, professional way. You wrap all your executable code inside a function, maybe called main, and then you protect it with this special condition, if_name_equals_main. This is a fundamental Python pattern. It's basically asking the question, was I run directly from the command line? If the answer is yes, then it runs the main function. But if this file is just being imported by another script, it does nothing. This simple trick gives you complete control over when your code actually executes.
And that's our journey. We went from a messy, monolithic script all the way to a clean, layered, and safe modular system. So I'll leave you with a challenge. Take a look at your current project. What's the very first piece of logic, the first group of functions that you're going to pull out into its own shiny new module? Think about it. Thanks for watching.